Today we're going to talk about how to solve a standard maximization problem using the simplex method. First and foremost, to be a standard maximization problem, it has to meet the following conditions. First, the objective function that you see is to be maximized, and second, all the variables are non-negative, and the condition is met by the inclusion of the non-negativity constraints. The first thing that we'll do to turn a linear programming problem into something that we can use the simplex method on is we'll add slack variables. A slack variable is just a junk variable that we put in there so we can replace the inequality sign with an equal sign. So everywhere we have a constraint, everywhere we have one of these constraints, we will place a slack variable at the end of that constraint and turn all of those inequalities into equal signs. Those slack variables take up the slack of the inequality and represent the amount by which the inequality fails to equal the constant. So let's go ahead and try this. We'll take each one of these inequalities. We'll be adding a slack variable to each constraint. And we call these S1, S2 for slack 1 and slack 2. Each constraint will have its own slack variable, and we'll replace that inequality sign with an equal sign. So our first inequality looked like 2x1 plus x2 is less than or equal to 30. Now it's an equation, 2x1 plus x2 plus s1 equals 30. And we'll do this for all of the constraints. So move to the next constraint. We have x1 plus x2 plus s2 equals 21, and x1 plus 2x2 plus s3 equals 36. So the first step in solving a linear programming problem using the simplex method is to take all of the constraints and turn them into equations instead of inequalities. So that's step number 1. In step number 2, we need to take our objective function and rewrite it. So in step number 2, we'll take our objective function and we'll rewrite it. So rewrite the objective function. And what we do in rewriting the objective function is get all of the variables over on the left side and then the constants over on the right. So our objective function is p equals 30x1 plus 40x2. And we're going to rewrite that objective function so all of our constants are on the left side of the equation and all of our variables are on the left side of our equation and all of our constants are over on the right. So our objective function is going to look like 30x1 plus minus 40x2 plus p equals 0. So we took all of these variables from our objective function, moved them over to the left side to match the constraints that we just turned into equations. And since no constants are left over here and no variables are left over here, it's now equal to 0. So first, add slack variables to the constraints to turn them into equations. Step 2, rewrite the objective function with all of the variables on the left side and the constants on the right. And step 3 is to set up your initial simplex table or your initial simplex matrix. So in matrices, we have rows and columns. We're going to have enough columns for each one of the variables represented. So I have x1, x2, I have an s1, an s2, an s3, a p, and a place for those constants. Now the rows in our matrix will be made up of the coefficients from each one of our constraints and our objective function. So our first constraint had a coefficient of 2 for x1, 1 for x2, 1 for s1. We had no s2, no s3, no p in that first equation, and it was equal to 30. Move to the second equation. It had a coefficient of 1 for x1, 1 for x2. We did not have an S1, so put a 0 there. 1 for S2. We didn't have an S3, so a 0, and there's no P, and this was equal to 21. So keep doing this for each one of the equations that we just made up at the top. So our next row will look like 1, 2, 0, 0, 1, 0, and 36 over here on the far right. And then we have our objective function. I'm going to make a line to separate it from those constraints. So it looks like negative 30, negative 40, 0, 0, 1, 0. Oh, and it was equal to 0. All right, so this is our initial simplex table or tableau or matrix. Okay. So what we're trying to do is find those corner points. If you remember that from linear programming with graphing, what we're trying to do is find corner points. And if you did that properly, you would know that there were multiple corner points for each one of the problems. So right now, we're looking at this matrix, and we have two different types of variables. So we have these variables that have columns that have numbers in them. These are called non-basic variables, and when you have an equation that's non-basic, its value is equal to 0. And then we have our slack variables, and you'll notice the columns of these slack variables, we just have 1, 1, and the rest of the numbers in those columns are all zeros. These are called basic variables, and the basic variables are where we find the solutions to our matrix. So right now, this variable x1 has a value of 0, x2 has a value of 0, s1, since it is a basic variable, has a value of 30, s2, since it is a basic variable, has a value of 21, and s3, since it is a basic variable, has a value of 36, and p has a value of 0. So right now, x1 and x2 aren't equal to anything. We're looking for a maximum value, and we're hoping that it would be greater than 0. And this corresponds to many of your linear programming problems that had a corner point at the origin, 0, 0. So we know that this is not the best solution to this problem, so now we need to decide what is the best solution to the problem. So I'm going to go ahead and use my calculator. If you haven't already, come in and get the RowOps program from me. To load your calculator, first thing we need to do is put in our matrix. So if you'll hit second and x negative 1, it brings up the matrices window. Hit your over arrow key to go to edit, and just hit enter. We're going to be working with matrix A. So it's asking me for the size of my matrix. First, the number of rows. I have 1, 2, 3, 4 rows, so I'm going to type in a 4. And then the number of columns. I have 1, 2, 3, 4, 5, 6, 7 columns. So I'm going to put a 7 there and hit enter. And then I'm going to go ahead and type in the coefficients from my matrix. Okay, so I have my my numbers in there ready to go, ready to use this program. Hit your program button, and the program that we're going to be working with is something called RowOps. So hit enter once you get to RowOps and hit enter again. And you should see a matrix pop up, and it should be that matrix that you just entered in. So use your over arrow key, take a quick look at this matrix and see, all right, do all of the numbers match up? If any of these numbers are off, you need to go back and re-edit the matrix and get back in this program. There's no point in doing this, well, continuing with this problem if you have incorrect numbers. All right. So next, we need to decide which one of these columns is our pivot column. So for a standard maximization problem, what we do is we look for the largest, if you will, negative indicator. It's called the most negative indicator. So looking down here at the row for our objective function, I notice that 40 is the biggest negative number. So this is my pivot column. And then to find out what number I pivot around, I look and say, okay, what is the smallest quotient? So I'm going to use the number or the constant over here to the far right. And I'm looking for the smallest quotient between this constant and the numbers in my column. So I have 30 over 1, that's 30, 21 over 1, that's 21, and 36 over 2, and that is 18. Okay, so it looks like this number is my smallest quotient. That means that this is my pivot position. So the idea of pivoting is that we will find a new corner point, and thus a new solution to this problem. So what we're doing is changing our corner points now. A quick rule about your pivot position: the number that you pivot around should never be 0, and it should never be negative. So if one of these numbers would have been negative in this column, I could have eliminated it from the start and said that is not my pivot position. So 2 is our pivot position. What we're going to try to do is take this column, x2, and turn it into a basic column. And we have those three rules that we're allowed to do for matrices. The first is we can multiply some number into a row, so every entry in this row could be multiplied by some number. The other option is we can take a multiple of one row and add it to another row. Every time that we're trying to get a 1, and we'll always try to get a 1 in our pivot position, we're going to use the trick of multiplying a row by a number. So what number could I multiply with 2 to get 1? And the trick is always going to be to multiply by the reciprocal. So what we're going to do is take the reciprocal of 2, which is 1/2, and multiply it with that row that contains the 2. And it is in the third row. So 1, 2, 3, it's in the third row. In your calculator, if you'll hit enter, you have the option of number 2 to multiply. And it asks what row. We're going to be multiplying row 3, so hit enter, by 1/2 and hit enter. So this brings you the new matrix 2, 1, 1, 0, 0, 0, 30. 1, 1, 0, 1, 0, 0, 21, and 1/2, 1, 0, 0, 1/2, 0, and 18, and negative 30, negative 40, 0, 0, 0, 1, 0. So we haven't created any type of new solution yet. We haven't transformed this column into a basic column. We have turned our pivot position into a 1, and now we need to turn all of the other numbers into zeros. The trick to turning all the numbers into zeros is to add a multiple of one row to another row. So what that means is I could multiply my pivot position by any number I want to and add it to any of these numbers to create 0. And the trick here is to always multiply your pivot position by the opposite sign of the number you want to cancel. So what could I multiply with 1 and add it to 1 to get 0? Negative 1. So the first thing I'm going to do is negative 1 times row 3, that's my pivot row, plus that row I wanted to change, which was row 1, to create a new row 1. I also want a 0 here, so same trick. What could I multiply with 1 and add it to positive 1 to get 0? So negative 1 times row 3 plus row 2 to create a new row 2. This one we're leaving alone. It's a 1. We have it the way we want it already. But we also want to turn this into a 0 so we get a basic column. So how do I get rid of this 40? Or what could I multiply with 1 and add to 40 to get 0? And that's positive 40. So 40 R3 plus R4 to get a new row 4. Now we don't have to worry about the actual calculations of this. This can all be taken care of in your calculator. So in your calculator, if you'll hit enter again, it'll bring back up some options, and one of those is called to pivot. So we're going to choose option number 3 to pivot. And then it asks us what our pivot position is. And our pivot position is in row 3, column 2. So enter in the 3 and the 2. And that tells us, or that brings us to a new matrix. And our new matrix looks like I'm going to go down when I write mine just because it's quicker. And then I'm going to scroll over. Let's see. Use your arrow key. You can scroll over. You can look at the rest of your matrix. Okay, so right now we have this column, which was x1, still a non-basic column, so this still equals 0. This we turned into a basic column because now it's a column that has a 1 and the rest zeros. So determine the value of x2, find that 1, go all the way over to the right-hand side. So x2 is equal to 10. S1 is equal to, so find that 1, it's still a basic column, equal to 12. S2, find the 1, go all the way over, is equal to 3. And P, oh, I missed S3. S3 is equal to 0. We took that from basic column into non-basic column. And the last column, P, or our objective function, is now equal to 720. So this is a new corner point, if you will, if we were graphing this, and the value of this corner point when x is 0, or x1 is equal to 0, and x2 is equal to 10, is 720. Using the simplex method, we know that we're done when we no longer have negative indicators in our indicator row. So looking down here at our objective function, we still have a negative number in our indicator row. So that tells me that I actually haven't found the maximum solution. Since this is the greatest or most negative indicator, and now our only indicator, this has become our pivot column. So I found a better solution, but not the maximum solution. So this has now become my pivot column, and I need to decide what number up here I'm going to pivot around. And I'm going to get out of my program here. If you'll hit enter, 4, and clear, it'll get you out of the program. So I can do the quotients. So to decide where your pivot column is, we look for the most negative indicator down here in the bottom row. To find your pivot position within that column, we look for a small or the smallest quotient. So I'm going to do 12 divided by 3 halves and 3 divided by 1 half and 10 divided by 1 half, and see which one of these gives me the smallest number. Now the reason that we do this is because we're looking for the smallest amount of material used, if you remember some of those application problems. So this gives me a value of 8, and this will be 6, and this will be 20. Okay, so we're looking for the smallest quotient. The smallest number is right there at the 6. That means this middle 1/2 is now my pivot position. So the same thing as before, we're trying to turn this into a 1 and the rest of these numbers into 0 to make this into a basic column instead of a non-basic column. So our trick for getting a 1 is to multiply by the reciprocal. So the reciprocal of 1/2 is 2, and I'm multiplying it by the 1/2 that's in the second row. So 2 times row 2 to create a new row 2. Now if you got out of your program, just hit the program button again and back to row ops and hit enter, and it should have that last matrice that we used saved in your calculator. Hit enter, and we're going to do option number 2 to multiply row 2 by 2. Alright, I'm going to do this all at one time instead of rewriting that new matrix. Now this thing has become a 1. So this number up here, by doing 2 times row 2 to create a new row 2, has become a 1. So how do I get these things to turn into zeros? The matrix operation is add a multiple of one row to another row. So what could I multiply with 1 and add it to 3/2 to get 0? And the answer is -3/2. So when we get those zeros, we're going to be doing opposite signs. When we want to get a 1, we're going to do opposite fraction. So -3/2 times our pivot row plus the row we want to change to create a new changed row. I want to get rid of this 1/2, so I have -1/2 times my pivot row plus the row I want to change creates a new changed row. And I want to get rid of this -10, so I'm going to do +10 times row 2, which is my pivot row, plus the row I want to change becomes a new changed row. So this thing, this matrix operation, is taken care of under to multiply. And we did row 2 by 2. And all of these things, these zeros, are going to be taken care of in our calculator under the to pivot function. And we'll be pivoting around row 2, column 1. So our 1/2 was in the second row and the first column. So in your calculator, now choose option number 3, and we'll be pivoting around row 2, column 1. So the new matrix that we've yielded looks like, and I'm going to write it down real quick and we'll talk about it. Uh-oh, I missed a row. This should be P. So I've missed. Okay, I missed writing down one of my columns there. So this should be what your matrix looks like. Notice that X1 and X2 have now been turned into basic columns because they are just one single number and the rest zeros. And to determine their value, we find the 1, go all the way over to the side of the matrix. So X1 is equal to 6, X2 is equal to 15, S1 is equal to 3, and now since this is not a column with just a 1 and the rest zeros, it's called non-basic and it's equal to 0. S3 is also equal to 0. And P is equal to 780. And since we have no more negative indicators down here in the bottom row, this is our maximum solution and our problem is solved.